Hello everyone, I'm Ganesh Raghavendran. Today we are gonna look into the Geometry Bridge Course Session 2. Uh, in Geometry Bridge Course Session 1, we looked into the straight lines and we also covered circles in conic sections. In this session, we are gonna cover parabola, hyperbola and ellipse conic sections, and we are gonna also solve a problem of each. We are gonna also look into how to classify equation given as parabola or a hyperbola or ellipse. Such type of questions are frequently asked questions from these sections in competitive exams like IIT JEE and JEE mains. So let's start. Uh, we have already seen the section circles in previous bridge course session. Now we are gonna look into ellipse, parabola and hyperbola. And this GIF image you guys would have seen in a previous bridge course session, that is how uh, circle or ellipse or parabola or hyperbola is made from conic sections. Let's start with ellipse now. So an ellipse. So an ellipse is defined as the locus of a point which moves such that the ratio of its distance from a fixed point to its distance from a fixed straight line is always constant and less than unity. The constant ratio is denoted by E and is known as the eccentricity of the ellipse. We will actually go through what this definition exactly means. Okay, let's see here. Let's draw ellipse. Yeah. Okay. So if you see here, this is an example of ellipse that I have drawn. An ellipse is a locus of point such that the distance between any point on the ellipse, for example, if we take this point, if we take this point and then the distance between this point and the fixed point that we have on the ellipse can be called focus point. There are two focus points on the ellipse and they are called foci together, and this distance, let this distance be d2, this distance be d1. This is some fixed straight line called directrix. This fixed straight line is called directrix. So it's given the locus of the points such that the distance between the point and the fixed point on the ellipse and the ratio of that distance to the distance of that point uh, from the fixed straight line is constant. So that is d1 by d2. This distance by this distance is constant, which is equal to eccentricity, is what given in the definition. Eccentricity is always less than 1. Eccentricity has two definitions. Eccentricity is either the ratio of A by C. I'm sorry, C by A. Here, the distance between the center of the ellipse and the focus point is C. The distance between the center of the ellipse and the vertex of the ellipse is denoted by A. There are two vertices on x-axis, two vertices on y-axis. Since the focus points lie on x-axis, the x-axis is called major axis here and y-axis is called minor axis here. So x-axis is major axis y-axis is minor axis, right? What if we have a ellipse like this? What if we have ellipse like this with focus points lying on y-axis? Then y becomes the major axis and x becomes the minor axis, right? So now here the distance of the directrix from the center of the ellipse is given by x equal to a square by c. Here it's denoted by x because the center of the circle is also origin. Center of the ellipse is also origin in our case, right? The center of the origin is placed, the center of the ellipse is placed on the origin. So we are denoting the distance of the straight line by x. X equal to a square by c is the length, distance of directrix from center of the ellipse. Okay. So now here you can see eccentricity is given by ratio c by a. The distance c is always less than the distance a, right? So the value of eccentricity is always less than 1 since c is always less than a. Okay. Now eccentricity is also given by another definition. E is equal to root of 1 minus b by a square. In this case, why? Because in this case b is the distance of the vertex on the minor axis from center of the ellipse. A is the distance of the vertex from the on the major axis from the center of the ellipse, right? So if we have ellipse like this, if we consider this ellipse, I'm sorry, there was a small glitch. Um, yeah. So when we consider this ellipse, where y is the major axis and x is the minor axis, we get eccentricity is equal to 1 minus a by b the whole square, right? Because here a is the distance from the vertex on the minor axis to the center, and b is the distance of the vertex on the ellipse from the center in the major axis. So you can actually write eccentricity based on this definition: E equal to root of 1 minus uh, minor axis by major axis. This definition will be more general, and you can use this definition to solve problems, and also this definition E equal to C by A. So these two definitions are important for solving any problems involving ellipse shape. Now let's see how how to derive the standard equation of ellipse. Okay, this is not much important, but it will give you an idea to solve the complex problems involving ellipse, and what is the uh, root idea or the basic idea for solving the problems involving ellipse. I will be doing the derivation for the ellipse right now, and case for hyperbola will be the similar, and then I expect you guys to try the hyperbola derivation and to check if you can get the derived standard equation for hyperbola. Let's start. For ellipse, let's have the diagram. One second. Okay, let's have this ellipse diagram and then try to derive the standard equation for ellipse. Now, let's see what is the uh, distance, total distance of d1 plus d2. There is another definition for ellipse, that is the distance of a point, uh, or it's a locus of the point, for which the sum of the point, the sum of the distance of the point from on the ellipse to the two focus lengths remains constant. That is, this d1 plus d2 remains constant always. This is an alternative definition for ellipse. That is the locus of the points where the sum of the distance of the points on the ellipse from the foci of the ellipse are constant. So the d1 plus d2 is constant. Now let us consider the case when the point x comma y is here, because this point, I will change the color, this point also lies on ellipse, right? So we can also consider this point x comma y. When we consider this point x comma y, the distance between this focus point and x comma y is this length plus this length. We know this length is a, right? So this length is c, a plus c, and this length is also c. So this length is a minus c, right? I will redraw the ellipse in this case for clarity. X comma y, there are two focus points, and this will be d1 and this will be d2. So this is minus c comma 0, this is c comma 0, and this is a comma 0. In this case, d1 is given by a plus c and d2 is given by a minus c. So the total distance which remains constant here, d1 plus d2, is equal to 2a, right? Now this 2 distance remains constant, that is 2a. We are going to have this as the base, and we are going to try to solve the try to get the standard equation of the ellipse. Yeah. Now let's consider a general case. Let's consider this diagram. in this diagram, x comma y is some arbitrary point on the ellipse, and d1, we have found that d1 plus d2 equals to a, and d1 is given by, we know the distance between 2 points, right? We have covered that in previous bridge course. Is given by x minus minus b the whole square plus y minus 0 the whole square, and d2 is given by x minus c the whole square plus y minus 0 the whole square, and d1 plus d2 is given as 2a. Now rewriting the equation, x plus c the whole square plus y square equal to d1 plus d2 equal to 2a. So we can write d1 equal to 2a minus d2, right? 2a minus root of x minus c the whole square plus y minus 0 the whole square. Now we can actually take square roots on both the sides. By taking square roots on both sides, we get x square plus 2cx plus c square plus y square equal to 4a square minus x square plus c square plus y square. Okay. So this is the form we are getting. By rearranging, we get 2cx equal to 4a square minus 4a x minus c the whole square plus y square minus 2cx. So 4cx minus 4a square now dividing both sides by 4 and taking square on both sides. Now expanding here we get now taking a square minus c square as common here. We can actually, there is a formula saying that b square plus c square is equal to a square. Sorry. B square plus c square is equal to a square. By using that formula here, this is the case in ellipse. Dividing by a square, b square throughout, we get So this is the standard equation of ellipse, and this is how we have derived it by using the definition of ellipse, that is the distance between the point on the ellipse and two foci lengths. The sum of them is always constant. The sum of them is 2a, we have found it as, and by using that uh, definition, we have derived the standard equation for ellipse. Right? Yeah, as you can see here in this diagram, right? This distance and this distance, this being two focus points or foci of the ellipse, the sum of these two distance is always constant. I'm sorry. Yeah. So here, this is an example of ellipse diagram, and here standard equation of ellipse we have derived it already. So with foci f1 and f2 on minus c comma 0 and c comma 0, and ab and some arbitrary point x comma y, we have done the derivation, and we have got the standard equation to be this, right? Now here, where b square is equal to a square into 1 minus e square, right? So when we were solving the equation, uh, we had identity like this, right? B square plus c square is equal to a square. How did we get it? Because we use two formulas for eccentricity, right? Eccentricity is given by c by a, and eccentricity is also given by root of 1 minus b square by a square, where b is the distance of the vertex in the, sorry, distance of the vertex in the minor axis, and a is the distance of the vertex in the major axis. So by using this, by equating these two uh, quantities, we can get this identity: b square plus c square is equal to a square as our eccentricity, as a identity which we have used in the derivation of the standard equation of ellipse. So what is this? The point A and A dash, where the curve meets the line joining the foci S and S dash, are called vertices of the ellipse. The coordinates of A and A dash are a comma 0 and minus a comma 0 respectively. I'm sorry for the bad diagram. I like to draw the diagram for this. Yeah, this y, this x, this is a comma 0, this is minus a comma 0. These points A and A dash are vertices. Vertices are nothing but the points on the ellipse which are intersecting with the axis, right? Like this is a vertex, this is a vertex, this is a vertex, and this is a vertex, right? So these are the points which are points on the ellipse which are intersecting with the axis, major axis and minor axis. So there are like four vertices. But then like usually when we are dealing with ellipses, when we are solving problems with ellipses in competitive exams like IIT JEE and JEE mains, uh, we won't be having a ellipse with center with at origin, right? Normally it won't be the case. There'll be some arbitrary equation, there'll be some general equation with some like random coefficients. So or there will be you'll be given a directrix and a focus, and you'll be asked to find the equation of the ellipse, like that. So just in this case, just for the understanding, like we are having the major axis and minor axis as x and y, but then usually major axis and minor axis are nothing but the axis which is passing through the foci of the ellipse is the major axis, or you can say a line passing through the foci of the ellipse is the major axis. And for example, like if I am having some arbitrary ellipse like this, uh, if I am having arbitrary ellipse like this, and I am having two foci here, so the line passing through the foci is the major axis, and the line which is perpendicular to the line passing through the foci and passing through the center of the ellipse is the minor axis. This is center. This is F1, F2, foci of the ellipse. Foci in foci figure S AE comma 0, S dash minus AE comma 0 are foci of the ellipse. Uh, why they have given A is we know that eccentricity is equal to C by A, right? So C, which is the focal length, is AE. So that's why this C comma 0 and minus C comma 0, which we have denoted in previous diagram, is being denoted as A into E. That is the length of the vertex from the center of the ellipse multiplied by the eccentricity. Directrix zk and zk dash are two directrix of the ellipse, and their equations are x equal to a by e and x equal to minus a by e respectively. So a by e, we know that e is equal to c by a, so x equal to a square by c or x equal to minus a square by c respectively. That is, in this case, if this is the ellipse uh, with center at origin and with x as the major axis and y as the minor axis, then we have directrix on both sides, right? Here I would like to go back to the definition of the ellipse. Right. So we told that the d1 by d2 is constant here, right? Like for an ellipse, the definition of the ellipse which is given according to the slide. If you take any line, any arbitrary point, it is like that. So that is how you draw a ellipse. Like how you draw a circle. You fix a center and you fix radius, and then like manually you take a compass, you fix a center with one point, and then with constant length you draw a circle, right? But drawing an ellipse is different. Um, drawing ellipse is different. The ellipse can be drawn by fixing the ellipse can be drawn by fixing a straight line, okay, and by fixing a focus point, some focus point as C, and then like the you need to draw the points for around this focus point such that the distance between this and the distance between this are in constant ratio. In this, I'm sorry, not this one, this distance between this and distance between this. So this should be in constant ratio always. So if you draw points in such a way, and then if you connect all the points, then you get ellipse. Here in this slide, eccentricity of the ellipse is given. The eccentricity of the ellipse for given for this given equation is given by e equal to root of 1 minus b by a the whole square. We have discussed this earlier, like what is eccentricity and what are the two ratios of eccentricity that we can see, and then how to relate those two equations and get an identity which we can use to solve, which we can use to derive the standard form of ellipse. Like you can see the different forms of ellipse with different eccentricity. Now we will look into the question. Find the equation of the ellipse whose foci are 4 comma 0 and minus 4 comma 0, whose eccentricity is 1 by 3. So we know the standard form of equation for ellipses. Right? This is the standard form of equation for ellipse. Here the foci are given as 4 comma 0 minus 4 comma 0. So from this you can see that like 4 comma 0 is here, minus 4 comma 0 is here. This means it's equidistant from the center. The focus is always equidistant from center. And from the given points you can see it is equidistant from origin. So that makes center as our origin. So 0 comma 0 is our center, and we know that uh, the distance between the center and the focus point gives us c. So c is equal to 4, right? And we know eccentricity is given by c by a, which is equal to 1 by 3, right? So which gives us uh, 4 by a is equal to 1 by 3. So a is equal to 12, right? A is equal to 12. Now we know that equation in x square by a square plus y square by b square is equal to 1. In that equation, uh, we know a, we have to find b, right? We can directly use this equation because the center is origin, and the focus point or equidistance, they are the major axis and minor axis are parallel to x and y axis respectively, so we can easily do this. But we do have complex problems in these cases where it is not the case, like the x-axis y-axis will be like this, and the ellipse will be like this, so it will be some random direction. We will be looking that sort of problems with parabola and hyperbola, and there are like mix a lot of problems which you guys will be probably be facing may probably be facing those problems in problem sets. I will do the simple problem here for this, and the more complex problem for parabola and hyperbola. The ellipse problems, the complex problems in ellipse also has to be approached in a similar way to the problems that we are going to approach parabola and hyperbola. Okay, so we are using x square by a square plus y square by b square is equal to 1, because center is 0 comma 0. If center is not 0 comma 0, center, let center be some h comma k, but it is still what do you say, it is still equidistant from the focus point which is given and everything. X minus h the whole square by a square plus y minus k the whole square by b square equal to 1. So this is the equation we will be getting. Now since center is 0 comma 0, we can write x square by a square plus y square by b square is equal to 1. Remember that we have derived the standard form of ellipse by considering 0 comma 0 the origin as the center of the ellipse, right? But that is not always the case. Now here we have found a is equal to 12. A is equal to 12. We also know that eccentricity is given by root of 1 minus b by a the whole square. So eccentricity is equal to 1 minus b by 12 the whole square, which is equal to 1 by 3. Eccentricity is given as 1 by 3. So 1 by 9 is equal to 1 minus b by 12 whole square. we'll get b square by 144 is equal to 8 by 9. B square by 144 is equal to 8 by 9. So b square is equal to 8 into 144 by 9, which is equal to 2 root 2 into 12 by 3. So b is equal to 8 root 2. So b is equal to 8 root 2. Sorry, 8 root 2. A is equal to 12. B is equal to 8 root 2. So a square is 144. B square is, B square is, so, A is equal to 12. B is equal to 8 root 2. So a square is 144. B square is 128. By substituting this in our equation, we get x square by 144 plus y square by 128 is equal to 1. So this is the equation of our ellipse that we have obtained. Now let's come to parabola. Parabola, we have discussed parabola in a previous bridge course, like what parabola looks like, and then what parabola should not be compared to. Parabola is not a arc of a circle. So like you can see this funny GIF image, like where the parabola is like what do you say? You throwing a ball or like throwing an object or something into the air, and parabola is like the convex lens or convex, I mean you can say it as convex mirror, the mirrors which are used usually inside a torchlight. Like when you see a torchlight, you will be having a bulb and then a curved glass, right? Like this, curved glass and a bulb, right? So this curved glass has a shape of a parabola, and let's see what is the definition of the uh, parabola. Parabola is actually defined as, one second. Okay, so parabola is like similar to ellipse. It also has a standard point, like it also has directrix, it also has a focus point, but then the definition of the parabola is a little bit different from the definition of the ellipse. We'll see what is the exact definition of the parabola. Let me draw a parabola here. Okay. 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 Uh, Parabola is the locus of points or the set of points that are drawn such that they are equidistant from a fixed point and fixed uh, straight line. That is, P naught F is equal to B1 P naught, or I will change the notation. Yeah, let it be B naught B1 B2. So P naught F is equal to B naught P naught. P1 F is equal to B1 P1. P2 F is equal to B2 P2. So the points on the parabola are equidistant from the focus. The fixed point is called focus, uh, or equidistant from the focus and a fixed straight line. And this fixed straight line is called directrix. It is called directrix. And for example, like normally how we when we draw the ellipse, we have a major axis and minor axis as x and y to get the standard equation of ellipse. We also have the axis for parabola as x-axis and y-axis to get the standard equation of parabola. Yeah. Let this be directrix. Now, what will be the distance of the directrix and vertex of the uh, parabola? This is the vertex of the parabola, the point where the parabola intersects the axis. So here, if you see the distance, and if you take this point on the parabola, that is the vertex of the parabola, let it be some x comma y. Since it lies on x-axis and y-axis, so it can be 0 comma 0. We can take it as origin, and let this f be at some distance a comma 0. And when we, by definition of the parabola, we know all the points on the parabola are equidistant from the uh, fixed point of the parabola, that is the focus of the parabola, and the directrix of the parabola, right? So since this distance, let this be O origin, OF is equal to A, then this point, let it be B. OB should also be A, right? So the directrix is nothing but like a straight line that is um, parallel to the line passing as a tangent at the vertex of the parabola. This is the tangent. This is the tangent of the parabola, right? So when we have a tangent of the parabola and the directrix is line parallel to the tangent of the parabola that is passing through the vertex of the parabola, and that is at equidistance as same as the distance from the uh, focus point, the distance between the focus point and the vertex. This distance and this distance is same, right? So um, like I'm using all these mathematical terms like tangents and directrix because like in IIT JEE and JEE means, even though you know the basic concepts of parabola, ellipse, hyperbola and everything, they will be using mathematical terms so that it's more important that you people know all the mathematical terms which are being used in whichever subject you are focusing on. So like those keywords are really necessary because that will give you an idea of what the question is asking for, what question is basically about. Now, so the since the distance of the directrix from vertex is also a, the b point is nothing but minus a comma 0, right? So this is basically the definition of parabola. The definition of parabola is very simple. The locus of the points which are equidistant from a fixed point and a fixed line, that will give you parabola. You fix a point, you fix some random point like this, and you fix a random line, and then just drop points everywhere which is equidistant to both the point and the line, then you will get parabola. So drawing a parabola is fairly easier and simpler than uh, drawing an ellipse. A standard equation of parabola. The standard form of parabola is taken with the origin as its vertex, like how we did before, and the focus lying on the x-axis. Let f be the focus, zm be the directrix of the parabola. Let p be the point and the parabola, and join fp and p drawn pm perpendicular to zm. So this angle is perpendicular. Therefore, fp equal to pm. So according to the definition of the parabola, this distance and this distance are equal, right? So fp equal to pm. And if you take this a comma 0, x comma y, then we know this should be what? This point should be. This point is on the same, has same ordinate as p point. Ordinate means y coordinate. So it has same y coordinate as p point. So y, right? And directrix is always at the distance of a, or the focal length from the vertex. So this is minus a comma y, right? So the distance, now you just need to uh, calculate the distance between 2 points, which you guys have covered in previous bridge course. Distance between p and f is given by x minus 0 whole square plus y minus 0 whole square. Distance between p and m, x minus of minus a, that is x plus a the whole square, x plus a the whole square plus y minus 0 the whole square, which when you solve you get x plus, sorry, y minus y the whole square. The y coordinate is same in both the cases, then you will get x plus a. When you expand and then equate both the terms, you will get this equation: y square equal to 4ax. Y square equal to 4ax, you will get this um, y square equal to 4ax, you will get parabola like this. For y square equal to minus 4ax, you get parabola like this. For x square equal to 4ay, you get parabola like this. For x square equal to minus 4ay, you get parabola like this. So you there are like a lot of questions that can be based on this. So the parabola can take either of these four forms, or like it can take a general form, like how we had a general form for circle, x square plus y square plus 2g plus 2gx plus 2gy plus c equal to 0. So it's like that, like the general form of the circle was like that. Similarly, the general form of parabola, the general form of ellipse, the general form of hyperbola will be in terms of like x square plus y square plus some coefficient into xy plus some coefficient into y plus some coefficient into x plus c equal to 0, something like that. You need to know how to classify each equation as whether it's a parabola or a hyperbola or ellipse or a circle. We'll be discussing about that at the end of this lecture. So we have discussed these things in the parabola diagram. The focus f is a comma 0, the directrix express a equal to 0, that is that nothing but x equal to minus a, the straight line equation x equal to minus a for the directrix. Vertex a is 0 comma 0 and axis af of the parabola is y equal to 0. So this one, this axis is called axis of the parabola, y-axis, where the parabola touches once and bulges outwards of the axis. For example, like I showed you different forms of parabola, right? Like facing upwards, facing downwards, and everything. So when you have like this, the axis of the parabola is y. When you have like this, the axis of the parabola is x. Right? This is axis of the parabola is y, axis of the parabola is x. Right? You can also have parabola that is displaced by some distance. For example, I can have parabola like this, right? So that is, it is displaced by some distance x, right? So if it is displaced by some distance h or something in x direction, you can write y square is equal to 4a into x minus h. And similarly, if it is displaced, I'm sorry, this is different equation. For this, x square equal to 4ay is the equation for this. For this case, it will be x minus h the whole square is equal to 4ay. And if you have a parabola like this, you can have equation as if it is displaced by some distance h again in x direction, you can have y square equal to 4a x minus h. So the general form of equation you can normally have it as um, sorry, the general form of equation you can normally have it as uh, y minus k the whole square is equal to 4a into x minus h, or x minus h the whole square is equal to 4a y minus k. Like depending on the shape of the parabola or the displacement of the parabola, you can choose any one of these equation, and you can substitute the value of h or k depending on the displacement. Sometimes the parabola will be displaced in both x direction and y direction. For example, the parabola can be like this. It is displaced by some, sorry, uh, the parabola can be like this. It is displaced by some distance h in x direction and k in y direction. So in this case, the equation will be x minus h the whole square is equal to y minus k into 4a. You can have equations like this. So it depends on shape and displacement of the parabola, how it is. Now we saw the focus, directrix, vertex, and axis of the parabola. Now we will solve a question with parabola. Even though since this is a bridge course, I'm kind of like rushing towards the sections parabola and the ellipse. Like I'll be solving a question with parabola right now, similar to the way that I have solved with ellipse. The key to understanding the concepts of parabola ellipse is to uh, try solving um, different kinds of problems. And there is a website called Desmos. In this website, you can actually put in the equation, and then it will display you the value. It will display you the graph actually for the particular equation which you have given. So that will be easier for you to visualize how the equation becomes a parabola, how the equation becomes a straight line, how the equation becomes an ellipse or a hyperbola, how it behaves. So I will be showing you a small demonstration of Desmos. Like after doing this problem for parabola, I will be inputting the values of the equation of the parabola which we are getting and equation of the directrix which is mentioned in the question in Desmos. I will be showing you how the graph turns out. Okay. Um, so find the equation of the parabola whose focus is minus 1 comma minus 2, and equation of the directrix is x minus y plus x minus 2y plus t equal to 0, right? So we know that in parabola, the point in a parabola, the distance of the distance between the point in a parabola and the focus, and the distance between the point on the parabola and the directrix uh, is same, right? They are equidistant. That's what we discussed earlier regarding the definition of the parabola. That's how parabola is constructed. So we have focus minus 1 comma minus 2, right? Let there be an arbitrary point x comma y on a parabola. So this point, the distance between x comma y and minus 1 comma minus 2 is root of x minus minus 1, minus of minus 1 is plus 1, the whole square, plus y minus of minus 2 is plus 2, so y plus 2 the whole square. This is the distance of the, I will just draw the parabola for reference. I mean, this is not how a parabola, this parabola will look like. I'm just drawing it as, like for example, I'm saying uh, the focus is minus 1 comma minus 2, and there is some x comma y point. This distance is what, this one, d1 is equal to. Now d2 is, um, let's have a directrix here, right? We need to find this distance between this point and line d2. So the distance between the point and the line, there is a formula for this, and there is also a derivation for this in the NCERT book. Like whoever is interested, like knowing the derivation, can go through that. It's an easy derivation. I will write the distance between the uh, line and the point. For example, you have a line with equation x1 plus by1 plus c equal to 0. Let this be some equation of line, and sorry, so let this be equation of the line ax plus by plus c equal to 0, and let there be a point x1 comma y1. You need to find the distance uh, between the point and this line, for which I have given the equation. Then that distance d, for example, that is, this is the line and this is the point. You need to find the perpendicular distance, right? How will you find that? So the d is given by, you substitute these points x1 comma y1 in the equation, in the expression ax1 by1 plus b, and take mod. Modulus means the absolute value, that is absolute value of -2 is 2, absolute value of any negative numbers become positive number, absolute value of positive number is also a positive number, absolute value of any real numbers gives you a positive component of that number, right? Like for example, absolute value of -43 is 43, and absolute value of any number gives you the positive number, because distance is always in positive term, right? Distance can't be negative. So d is this one by root of a square plus b square. Yeah. So this is the this formula for distance between a point x1 comma y1 and a line uh, capital Ax plus by plus c equal to 0. So this is the distance formula. Um, you can see this distance formula in CRT book, and you can also refer to the derivation. I'm not going to do the derivation here because it's kind of big and then somewhat unnecessary. But I'll just give you a hint, like while solving the derivation, there is a step where you get the uh, area of the triangle. So I'll just give, okay, let these 3 points given in Cartesian coordinate. So what will be, so, uh, okay, yeah. So what will be the area of this triangle when given 3 points? That will be, uh, take a point here x1 into y2 minus y3. You can come kind of in cyclic order. So x1 into y2 minus y3 plus x2 into y3 minus y1 plus uh, and here x3 into y1 minus y2. Area of triangle. Remember this formula. This formula is used in NCRT derivation. Like for people like who are not aware of this formula might find the derivation confusing. So this is it. Like you can check the NCRT book for derivation of the distance between point and a line. And remember this formula. This is also an important formula. Now we'll go back to the problem for parabola. Yeah. So the d2, now the distance between the point x comma y and the line x minus 2y plus 3 is given by x minus 2y plus 3. You are substituting the points x comma y in the equation. The x comma y is an arbitrary point, so let it be x comma y because we are going to find the equation of the parabola, by square root of the coefficient of x here, the capital A which I mentioned in the equation is 1, plus, and capital B is minus 2, the whole square is equal to x minus 2y plus 2 by root 5. This is d2. Right now we have to equate d1 and d2. So this d1 is equal to d2. Right? we'll do that. Root of x, sorry, x plus 1 the whole square plus y plus 1 the whole square is equal to x minus 2y plus 3 by root 5. Okay. So now taking square on both the sides to remove the root, x plus 1 the whole square plus y plus 1 the whole square is equal to x minus 2y plus 3 the whole square by 5. Right? Now expand it. X square plus y square plus 2x plus 2y, and you'll get 1 here, you'll get 1 here, and that will be equal to 2, which is equal into 5. The denominator 5 here gets multiplied here and equal to x minus 2y plus 3 the whole square. You get x square minus 2xy plus 3x minus 2xy plus 4y square minus 6y plus 3x minus 6y plus 9. Right? Okay. So 5x square plus 5y square plus 10x plus 10y plus 10 is equal to this. Right? Now we rearrange the terms and bring all the terms together. Wait, x square plus 4y square minus 2xy minus 2xy is minus 4xy plus 3x plus 3x is plus 6x, and minus 6y minus 6y minus 12y plus 9. Right? Now 4x square plus y square, and you bring these terms here, like the left hand the right hand terms to the left hand terms, and then simplify the terms. 4x square plus y square plus 4x plus 22y plus 1 plus 4xy is equal to 0. This is the equation of the parabola. And what is the equation of the directrix given? The equation of the directrix given was x minus 2y, x minus 2y plus 3 equal to 0. This is the equation of the directrix given. Now I will show you how to plot this in Desmos graph, because like you guys need to visualize these equations to make sense of these equations. These kind of formulas, like these kind of equations and everything, you need to learn, like if you are more interested in fitting the curves. For example, you guys would have uh, known machine learning, artificial intelligence and everything, right? So these kind of equations you need to learn, you need to know to how to fit the curve, fit the points. Like some arbitrary data is given, like how, which part does that, which trend does that data follow. Like for recently during this COVID-19 pandemic, the economists and everyone try to fit the data, like how COVID-19 is affecting the uh, how will it affect the people or country's economy in future, or when will COVID-19 pandemic situation be, uh, when will the rates will come down, when will it get reduced. So those kind of situations, economists try to fit the curve with the fit the data in the curve by using different equations. So you need to make sense of these equations to visualize it, like how will it be. So for those, these tools are really handy, the desmos.com. I will just show you how to use those tools. It's just for playing with it and then making sense of the equations which you are getting through these problems. I hope you guys can see the window, the desmos.com/calculator. There are like two there's like a box where you can enter the equations. Now first I will enter the Directrix equation. The Directrix equation is x minus 2y plus 3 equal to 0. You can see the line. This is the Directrix, and I am adding another expression. That is, this is the parabola expression which we got, 4x square. You can actually use a symbol on top of the number 6 in the keyboard. 4x square plus y square plus 4x plus 22y plus 1 plus 4xy equal to 0. Now you can see our parabola, how our parabola is. This parabola looks nothing like the parabola which we discussed in our while saying the definition of the parabola, right? Because this parabola doesn't have axis, proper axis like y-axis or x-axis. It's a random parabola. So this is how you get questions in IIT JEE means. This is how you need to solve. Like you need to think quick on your feet. Like okay, this is given, this is given. Directrix is given, focus is given. How to solve? Like if focus is given, one of the vertex of the parabola is given, how to solve? So that is how you need to work on. So now I will do the uh, hyperbola as well, and for hyperbola also I will plot the graph, and I will show you like how the hyperbola looks like after solving the equation. Yeah, so that's it for parabola right now. You guys need to practice like a lot of problems in parabola to get really comfortable with the type of questions which we are dealing here. Let's go to hyperbola. You can see hyperbola here. This is like a good illustration of the hyperbola definition. So we will see the hyperbola definition, and we will come back to this slide and then uh, see how it relates to the definition. A hyperbola is the locus of a point which moves in the plane in such a way that the ratio of its distance from a fixed point in the same plane to its distance from a fixed line is always constant, which is greater than unity. This is the definition given in the slide for hyperbola. The ratio here is also eccentricity. Eccentricity, yeah, it's given here. Sorry for writing over it. So this is also eccentricity. But if you see, the eccentricity in this case is always greater than unity, right? The eccentricity in uh, ellipse which we saw was always less than 1, right? Here the eccentricity is always greater than 1. And there is also an other definition for hyperbola which I would like to share. You guys like saw the image in the previous slide, right? I'll show you. You guys are seeing this image, right? This GIF image. Like the another definition of hyperbola is hyperbola is a set of all points in a plane, the difference of whose distances from two fixed points in a plane is a constant. Okay. So this is what the definition says. It says that it's a set of all points in a plane where the difference of whose distances from the two fixed points in a plane is a constant. If you see here, there are two curves, right? So you can actually make sense of this definition by this GIF image. This is a really very insightful GIF image. Now, if you look here, there are two curves. These two are the fixed points. These two are nothing but the foci of parabola. Foci of parabola. Now how you construct a parabola is I'm fixing 2 points like this I'm fixing 2 points, and I'm fixing 2 points, and then I want to plot points everywhere where the difference is same. The difference between that point and the foci. Okay, for example, if I'm taking this point, right, the point here, and uh, this length and this length, right? So when I do that, let it be d1, let it be d2. So I want to get the difference, d2 minus d1 absolute value. Okay, I'm not interested in the sign of the subtraction. That is like if d2 is 4 and d1 is 8, or d1 is 4 d2 is 8, it doesn't matter to me. The difference is always 4. So that is why, like here d1, let d2 be 8 here and d1 be 4 here. You get a point. Okay, when d1 is 8 and d2 is 4, you get a point here. The difference is same, right? The difference is always 4. It doesn't matter if it's minus 4 or plus 4. Just the difference between the two lengths is always same. So that is why you get two curves. That is because the difference it can be on either side. I hope you understand this. Like the difference, the sign doesn't matter, only the difference matters. There can be two sets of points where you get the same difference. That is why you get this curve, this set of point, and a mirror image of this set of point, right? So that is the definition of hyperbola. The hyperbola states that hyperbola is a locus of points. I'll just read the definition again. Now that I have explained it, you guys will be making sense of this definition very clearly. A hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points in a plane is a constant, right? So the constant difference is what makes the is what constructs the hyperbola. Um, Sorry. I'm sorry for the uh, okay. Sorry for a glitch. So this is what constructs a hyperbola. The difference between 2 points. So the difference between the point and the foci. Now we will come to this definition. A hyperbola is the locus of a point which moves in the plane in such a way that ratio of its distance from a fixed point in the same plane to its distance from a fixed line is always constant, which is always greater than unity. So as I told you, this is eccentricity. Eccentricity. The hyperbola is a locus of point. Locus of point is nothing but collection of points which moves in the plane in such a way that the ratio of its distance from a fixed point in the same plane to its distance from a fixed line is always constant, which is always greater than unity. Now you can see this. This P is the point on the hyperbola, and this Z dash is directrix. Yes, this focus point. So when you take this point, when you have some line directrix, and when you have a focus point, so you will be having this such that its distance from the fixed point is same to its distance from the fixed line is always constant. So this the, this this is always constant. PS by PM or SP by PM equal to E is always constant eccentricity, and it is always greater than 1. Now I would like to give an interesting idea about hyperbola. Hyperbola looks like this, right? And it goes on. Okay. Ellipse looks like this, right? What if you cut the ellipse down the center and then you invert it? You get like this, which is nothing but hyperbola. So this is an interesting thought, interesting idea. When you see, it will make more sense, like about the definition. The definition is kind of same, right? Okay. The ratio of its distance from the fixed point in the same plane to its distance from fixed line is always constant. In a ellipse also, the same definition was there with one small twist. The ratio is always less than 1. Here, the ratio is always greater than 1. When the ratio of the uh, distance between the point and the fixed point, the point on the curve and the line is greater than 1, it results in hyperbola. How you will see. We'll make more sense of it. This is hyperbola. Let it be some hyperbola. It has focus here, f1, f2. Let center be here, origin. Let us consider origin to be the center 0, 0. And we have directrix. Use different color. We have directrix here. As we had two directrix, right? Like for ellipse on either side of the curves to construct the two convex curves. Similarly, we have two directrix here, which is inward. Those directrix were outward. Like for ellipse, it was like this, right? Two directrix and the curves were like this. But here, hyperbola is different. The directrix are inward, and focus point is here, situated here, outside the directrix. Here, focus points were here, inside the directrix. It's kind of like a comparison. This comparison will make you more will make you relate hyperbola more to ellipse and then make more sense of it. So this is the case. And then what happens now is the directrix length, I mean the length of the point from the directrix and length of the point from the focus, d1, d2. And here there is another directrix, so d2 dash, d1 dash. So like there are two focus points, and then when you have two focus points and then two directrix, you will obviously get two curves which satisfies the condition uh, d1 by d2 is equal to d2 dash d1 dash by d2 dash is equal to e. There will be two curves that will be satisfying the condition. So that's why you see two curves like this. In ellipse also you get two curves, right? In ellipse also you get two curves, but these are two curves, but they join together. But here in hyperbola it's not the case. They don't join together, they extend infinite. Okay. And here you have to make sense why eccentricity is greater than 1. Let this focus point be some c. Okay. And of the vertex of hyperbola, let it be a. Vertex is nothing but the outermost point. Is similar to parabola. The vertex of the point, let it be distance a from the origin, and this is c. We know eccentricity is given by formula c by a. Here you can see c is greater than a, right? So which is greater than 1 because c is greater than a. Okay. And here you need to know like what is the distance of the directrix. Here also the distance of the directrix is same as the distance of, definition is same, a square by c. Now you see, if you observe it carefully, uh, x equal to a square by c is the distance of directrix from the center. Oh, I'm sorry. X equal to a square by c, the distance, right? If you see here, x equal to a into a by c, right? Since c is greater than a, this quantity is less than 1, right? When you multiply some quantity with a number less than 1, that will be less than its original quantity. So a into a dot a by c will be less than a, right? That is why a is here. This is the distance a, and this is the distance a square by c. For hyperbola, for ellipse it's different, right? For ellipse this is a, and this is a square by c. So this is how you can make comparison and see how it works. By understanding the concept of ellipse completely, you can actually understand the concept of hyperbola as well. It is similar, like the same concept. Every point the ratio is same, but the ratio is just greater than 1. That's all. Yeah. Now, like there is another thought here. We knew the eccentricity of ellipse and eccentricity of hyperbola. We didn't discuss the eccentricity of parabola, right? Parabola also has a directrix. You know that directrix equal to a square by c, the general condition. But in parabola, the directrix was mentioned as x equal to a, right? So here, how does directrix becomes x equal to a when we know that this is equal to a into a by c? This will become a when a equal to c, right? That means eccentricity. We know that eccentricity equal to c by a equal to 1. So for parabola, eccentricity is 1. So you can go back and check the uh, parabola slides again. You will see the directrix with x equal to a drawn. So and you can also see that eccentricity becomes 1 in parabola. Now in hyperbola, it's like a very common structure which you would have seen in cooling towers. I worked in a petrochemical plant for 2 years, and then um, I also have worked in cooling towers. So these are the examples of cooling towers. They have a hyperbolic structure throughout, and Pringle structure. Like I have explained this before, like how Pringles look like a hyperbola in session 1. Now the standard equation of the standard equation of hyperbola. You see, like we are gonna use the same kind of condition for derivation. In derivation of ellipse, what did we use? Because like we had a the distance, and we used the yeah, for ellipse we used the sum of the distance to be constant, right? Here we used I also explained in hyperbola the difference in the distance is constant, right? So the similar concept, you just have this x comma y here. You just have this x comma y here, and now you find the difference. What it will be? This is this is a, this is a, this is c, this is c. So when you have x comma y here, and this distance will be 2a plus c, right? And this distance will be, I'm sorry, this distance will be c, right? So 2a plus c minus c, this is equal to 2a. 2a is the difference here. So 2a was the difference there as well. I mean 2a was the sum there, and 2a is the difference in the distance here. So similarly, you have the point x comma y, you have minus c comma 0 and c comma 0, and you also know the identity b square plus c square is equal to a square, right? And with those informations, like you can find out what is the standard. You can derive the standard equation of hyperbola, and here I'm sorry. Here b square plus c square is equal to a square. You use the formula here like this. B square plus c square is um, sorry, b square plus a square equal to c square. This is for hyperbola. For ellipse, b square plus c square is equal to a square, right? Um, you use this condition for a derivation as well. You can get it. How you get this direct condition is, for example, uh, this is a hyperbola, and in this hyperbola, you get this is a, right, and this is c, right, and you need to find some value b, like it will be here b. So here we define b as, we define the b, and then the b will be, yeah, we define the b, and then b is known as the length of conjugate axis. This is conjugate axis. This is I guess tab. Um, so if you understood the definition of hyperbola properly, you can easily do this question. Like, even though when you first look at the question, it may look confusing, but it is not. What is next page? Like, I'm just drawing the hyperbola, but then in exams you won't be having time to draw the graph and then do the problems. You can just try those techniques at the start to get the hang of it. So the focus is 1 comma 2. I'm just drawing this axis randomly. Don't consider this axis to be y and x. These are just conjugate and transverse axis. The focus is 1 comma 2, and directrix is 2x plus y equal to 1. The directrix is 2x plus y equal to 1. Directrix, this is uh, conjugate axis, and this is transverse axis. Okay, so now by definition of I'll use the color. Yeah, I'm sorry. By definition of a hyperbola, you know that for any point that is lying on hyperbola, the ratio of these two distances is greater than 1, and it is given by eccentricity, right? d1 by d2 equal to e, right? So we know that let this be some point x comma y. d1 is given by the distance between 2 points, so x minus 1 the whole square plus y minus 2 the whole square, yeah, and d2 is given by um, the distance between the point and line. The directrix, we can write it like this, so 2x minus y, sorry, plus y minus 1 by root of 2 square plus 1 square, that is 5, right? And d1 by d2 equal to e. So you can also write d1 square by d2 square equal to e square, and the eccentricity is given by root 3, okay? So d1 square by d2 square is equal to 3. Okay, we can solve this equation. d1 is, okay, 1 second, hold on. Yeah, now d1 square by d2 square equal to 3. Eccentricity is given by root 3. Eccentricity is given by root 3. So d1 square by d2 square equal to 3. So d1, we know d1 square is x minus 1 the whole square plus y minus 2 the whole square. I'll just check the question. Yeah. So this is d1 square is equal to 3 into d2 square. d2 square is this one, right? 2x plus y minus 1 the whole square by root 5 the whole square. Now you need to expand this and solve this. X square plus 2x plus 1 plus y square plus 2y plus 4 is equal to 3 into 4x square plus 2xy minus 2x plus 2xy plus y square minus y minus 2x minus y plus 1 by 5. So you take that 5 this side and multiply 3 here. You get 5x square plus 10x plus 5 plus 5y square plus 10y plus 20 is equal to 12x square plus 2xy plus 2xy is 4xy, so 12xy, and minus 2x minus 2x minus 4x, so minus 12x, minus y minus y gives you minus 2y minus 6y plus 3y square plus 3. Yeah. Now bringing the equations together and then simplifying them, you get 7x square plus 12xy minus 22x minus 2y square minus 16y minus 17 is, okay, I'm sorry, here 5 plus 20 is 15. See, 5 plus 20 is 25 minus 22. I'll just check once again. 7 square 12xy minus 22x minus 2y square minus 16y minus 22 is equal to 0. So this is the equation for, I'm sorry if this part has cut out. I'm just expanding the this equation. I'm writing it there. I'm sorry for getting that part cut out. I'll just write this, plot this equation in Desmos graph, and let's see how it turns out. Sorry, this means I made a small mistake. This is 4y. So by solving, you get 2y square minus 7x square plus 7 plus 22x plus 16y minus 12xy is equal to 0. So this is the answer you get as the equation for the hyperbola. And then directrix, you know what equation you are getting, right? Directrix, you get 2x plus y minus 1 equals 0. This given, the directrix equation is given. Now how will it look like when we plot it in the Desmos graph? I showed you like how to input the equations and then visualize it in Desmos, right? So similarly, we are gonna put the equations in Desmos. I have already put the equations in Desmos and have kept it ready. Now let's see how does it look like in Desmos graph. You can see here, like this is how it looks like. The red line is the directrix and the blue line is the hyperbola, the equation which we have entered. So you can see the hyperbola diverging on both sides. It looks uh, symmetric, right? Like if you take any point, random point, and then check the difference between, I mean, the focus is given. The focus is given as 1 comma 2, right? So you can take the focus. You can take the focus and you can put it in, and you can check like how does it work. How does it uh, work? Like how does the uh, difference between the each line difference, sorry, difference between the each point looks um like the eccentricity, if you are getting the eccentricity or not. You can check it. You can check if the equation is correct. I have solved this equation by using this, and I have put the display the equation on Desmos. You can check the equation, you can verify the equation if the equation is correct, and then you can try it in Desmos. And you can also solve similar questions um, in for IIT JEE or for JEE means, or for NEET or other competitive examinations, and you can get more trained in this. I just made some changes. So this is the final equation I'm getting, and then uh, this is the Desmos graph I'm getting. I changed the equation. So make sure you guys also verify once by doing the calculation, and uh, keep on trying the problems, and then look into the uh, try with Desmos graph to see how it behaves, so that like you can get an idea what you have done is correct or not. You can check this, and as you practice more, you'll get more practice with this. Because like how I found out my error was in previous graph, my focus was not inside the hyperbola. Now my focus is inside the hyperbola. Now I can see that okay, my graph looks correct. So this is how like you practice with Desmos graph, and then your calculations by checking if your equations that you have got, by checking that if the equations you have got are correct with the parameters that have been mentioned in the question. So keep on practicing, guys, and you can really score well with the geometry section. It's just straightforward. Once you get the concepts clear, it's just practicing the problems. You can make this kind of like mistakes, small mistakes by uh, errors. Like since I had a small space, I had to do some calculations in my mind. But then when you are given paper, I advise you to like try out each and every step, so that like you don't miss out on any step, you don't make any silly mistakes, and then you get the answers right. Yeah. Thank you, guys. I hope you have enjoyed this class, and then uh, this is this is all for the geometry section, the conic sections. This is all for the straight lines and conic sections of the 11th class. um, See you in next video, and then until then, take care and stay safe. Thank you. Bye.